Hello and welcome to this R tutorial. Today we're going to implement the k-nearest neighbors classifier on R. So let's start right now. The first thing we're going to do is to set the working directory. So right now I'm on my desktop. We're going to go to Machine Learning AZ folder, part 3 classification, and then section k-nearest neighbors. Alright, that's the folder we want to set as working directory. Make sure that you have the social network add CSV file. And if that's the case, you're ready to click on this More button here to set the folder as working directory. Here we go, that's done. And now we're going to use our classification template to be efficient and generate all the results in a flashlight. So I'm going to select everything from here to the top. There you go, copy. And paste it here. Right. And now we need to change a very few things. First, we need to create the classifier here. And we just need to change the titles of our plots in the training set results and the test set results. So let's do this right now so that we don't forget. I'm going to replace classifier by, so it's KNN. So we're just doing this to specify the algorithm that we're plotting. And here as well, classifier is replaced by KNN. Right, and now what we only need to do is to create our classifier. But first let's select and execute the preprocessing steps. So I just need to select everything from here and then press Command or Control to plus Enter to execute. That's done. Alright, so we have our data set. We can have a look. That's our data set, our training set, and our test set, which are well scaled. Okay, so as a reminder, the dataset contains information about users in a social network. The social network has a business client, which is a car company, that puts ads on the social network, and the social network gathered not only the informations like the age and the estimated salary of those users, but also took the response to these users to the ad, that is 0 if the user didn't buy the product, the car, and 1 if the user bought the product. So, you know, it's a very cool luxury SUV launched at a ridiculously low price. So a lot of people, when they saw the ad, said, let's do this, let's get the car. And we can see there are a lot of buyers. So yeah, as you can see, it must be a very cool car and cheap. So now let's go back to KNN and create our classifier. So the classifier is a KNN classifier, and to create this, we're gonna first import the right library. We need a library for this, which is, by the way, called class. So let's do this. So if by any chance the class library is not in your packages list, you need to install it using this command, install.packages, and in parentheses and in quotes the name of the class, which is class. But I think you might have it by default, but if that's not the case, please write this command with class inside, then execute, and it will install it. But so here we're just going to write library and in parentheses class. So that selects automatically the class. You see that right now the class package is not selected, and once this is executed, it will select it automatically. All right, and now we're going to do something a little different, because usually, you know, we create our classifier here, and then we create this vector of prediction ypred using this predict function that we apply on our classifier and on new observations in a test set. But here, it's like we're going to do these 2 steps all in once, because we're actually going to remove this line, and we're actually going to replace this comment fitting K and N to the training set and predicting the test set results, because all in once we're going to fit k and n to our training set and predict if the users of our test set buy yes or no the SUV. So you're going to understand why. We're going to directly create our vector of prediction ypred here, and then, you know, before we had classifier equals then the SVM or logistic regression. Here it's going to be directly ypred equals KNN, because actually this KNN function here will return the predictions of the test set observations. Okay, so now let's have a look at this KNN function and you'll get it. So press F1. Okay, so K nearest neighbor classification. Let's first input the arguments. The first argument is train. So you can guess that by train they mean the training set. So here we need to specify what the training set is, and actually since we call it training set, it's training set. So training set here. All right, training set. However, the training set, as you can see, contains the independent variables and the dependent variable, and we only need to take the independent variables. We won't include the dependent variable in the KNN function here. So here we need to take only the first two columns. So we're going to add a bracket here and then comma, because on the left of this comma is all the lines that I'm taking, all the observations, and at the right of this comma is the columns I want to include in the training set. So it's all the columns except for the last one. So I'm going to put here -3, which means that I'm removing the last column of my training set. All right, so that's done. That's what we have to input for train here. So train is your training set, but without the dependent variable. Then comma, and then let's add the second argument. So the second argument is test. So you can guess what it is. It's going to be the same. Test equals test set, of course. All right, so test set. And then same as training set, we're going to remove the dependent variable because anyway, we are supposed not to know the results. We want to predict the observations of the test set. So anyway, we need to remove it. So comma to take all the lines and -3 to remove the last column. Okay, so we have our training set and our test set. And now what is the next parameter? Okay, the next parameter is CL, factor of true classifications of training set. So can you guess what it's going to be? Okay, let's see. CL equals, in your opinion, what is it going to be? Well, you know, to train a classifier, the classifier needs to have, okay, the independent variables, but it also needs to have the dependent variable because it needs to have the results to, you know, find the correlations between the informations of the independent variables and the information contained in the dependent variable. So here, since we only have the info about the independent variables, we also need to include somewhere the info of the dependent variable. And that's what we add here. That's the CL, so factor of true classifications of training set. That is the categorical dependent variable. So let's do this. So to take this vector actually, so as you can see, that's the last column of the training set. So it's going to be training set, taking all the lines, all the observations, and then the 1, 2, 3, so third index of the column purchased. So let's take that, training set, bracket, comma, and then 3, because the column we want is indexed by 3. All right, so that's for the third argument, and then we have one more argument, which is the number of neighbors. So let's add this one. So remember in Python we took 5 neighbors. That's actually the default parameter. So here we're going to take the same that will allow us to compare the results we obtain on Python and R. So it will be interesting. So let's take k equals 5 neighbors. All right, and now we have everything we need. We can select this, and here it is, ypred, all good. So now let's have a look at ypred. We can have a look here, ypred. I'm pressing ypred in the console and press enter to have a look at it. And here are all the predictions for the test set. So remember, the test set contains 100 observations. So here we have 100 predictions corresponding to the same observations as these guys here. So for example, let's take the first observation, the first users. So let's take the 1, 2, 3, 4, 5. So the 5 first users. These 5 first users didn't buy the SUV in reality because the purchased variable equals 0 here, and that's the truth. That's what actually happened in reality. And what does our prediction say? 1, 2, 3, 4, 5. 5, 0 here. So correct predictions for the 5 first users. Okay, perfect. Then we have 4 ones. The 6, 7, 8, and 9th users actually bought the SUV. So great for the 6th one, the 7th one, great, correct prediction. 8th one, correct prediction as well, but the classifier made a little mistake here. But that's fine, it looks like it's making some correct prediction most of the time. And we are going to check that on the confusion matrix. That will be faster. It was just to, understand, to explain what YPRED was, but I think you get it. So here we just need to select this and execute. Here's CM. We can have a look at it in the console, CM. And that's the predictions. Okay, so we have 6 plus 5 incorrect predictions. So that's 11 incorrect predictions. So that's not too bad. And now what we're most interested to see is the prediction regions, how they behave, and especially the prediction boundary to see if it's going to be a straight line or something else. And actually you're going to see that the KNN is a non-linear classifier, so we will get something different than what we got for logistic regression. So I know it's supposed to be a template that works for every classifier, but the KNN classifier will be the only classifier we will need to change something in the template, besides the title, I mean. And that's because of this structure we changed here, For all our classifiers, we had this first section where we create our classifier with the, classifier equals, and then we create our classifier with the function. And then in another section, we create a YPRED using the classifier we built in the section above. But here, since we did both at the same time, we just need to change a little thing here in the template. So can you guess what it is? Okay, so it's actually in this line, because as you can see here, we are using the predict function on our classifier. But here, since we didn't create a classifier separately from the vector of prediction YPRED, well, that means that this predict classifier doesn't mean anything here. So actually it's really simple. What we only need to do is to replace this predict classifier new data equals grid set by this code here, because this is actually like the predict function, only it's creating the classifier and making the predictions at the same time. So there is not a predict function here. So it's very simple. What we only need to do is to take this, Command C, and here, since it's all the predictions of the pixel points in the grid, we will need to change this new data equals test set. So this test equals test set by grid set. So basically it will be very simple. We will remove this predict function here and paste that. And here we're just going to replace test set by grid set, because we want to predict if those imaginary pixel points that we picture as imaginary users of the social network will buy yes or no the SUV according to their coordinates in the graph, that is their age and their estimated salary. And then once the prediction is done, it will be colorized in the proper color. Green if this imaginary user pixel point is predicted to buy the SUV, and red if it's predicted not to buy the SUV. And that's it. That's all we need. So we're going to select this as well and paste it here to do the same for the test set. Of course, it's the same. And here we go. And then we're all good to plot the results. So let's do this. We're going to select this and let's see what we obtain. Command and Control plus Enter to execute. The graph, the plot is coming. You're going to see how the KNN manages to classify the two classes of users, those who didn't buy the SUV and those who bought the SUV. And here we go. That's the graph. That's the prediction boundary here. So you can see there are a lot of irregularities, but that's because of the way the KNN model works, because it's taking each time the 5 nearest neighbors. That's all the prediction boundary. These are our two prediction regions, the red one and the green one. All these points here are the real observation points, are real users of the data set, and their real results, whether they bought, yes, the SUV if it's green, and no, they didn't buy the SUV if it's red. So we can see that most of our predictions are correct because all the red points are in the red region and most of the green points are in the green region. We also see that the KNN classifier makes a much better job at classifying those users here that their logistic regression couldn't classify correctly because it was a straight line and some green points were falling on the red region. So here it's doing a much better job, and all those users with an age above the average and an estimated salary below the average are now well classified in the green region. So very good, very good. But let's not scream victory until we find out about the results on the test set, because since this is the training set and the KNN classifier was built on the training set, we might get different results on the test set. So let's see. We're going to select this. The test set results are ready. Execute. And these are great results. Most of the red points are in the red region. Most of the green points are in the green region. And of course we had a few incorrect predictions like these two guys here or these two guys here. But here it looks very good and we have made nice prediction regions. Okay, so that's it for this tutorial. I hope you enjoy discovering this new type of classifier. We are going to discover new kinds of classifiers in the next sections. I can't wait to show you this.